Hi! This is our assignment 2 for our Engineering Mathematics 1. The question given to us is set 36, which involves trigonometric integral. And these are the group members in my group. Alright. What is trigonometric integral, you might ask? Trigonometric integral is actually the integration of trigonometric functions. The general formula of it is the integration of sine with the power of mx times cos with the power of nx times dx. The common identities used for this topic will be from simple trigonometric rules. Alright. These examples will include sine square x plus cos square x equals to 1, sine square x equals to half times 1 minus cos 2x, and also cos square x equals to half times 1 plus cos 2x.
So the question that was given to us is to find integration of cubic sine x times cosine powered by 5x times dx. So as you can see, powers of both sine and cosine are odd numbers. So we can let u be either sine or cosine. So we decided to use cosine as u, as it's proven that it will be easier later on. After that, we differentiate u, which is equals to cosine x, and it will become du over dx equals negative sine x. Therefore, we can find dx, so it will be equal negative 1 over sine x times du. Also, we need to split cubic sine x, so it will become sine square x times sine x times cosine powered by 5x times dx. And then we subtract cosine and dx by u and negative 1 over sine x times du. After that, we can subtract sinuses, and then in the end we will have negative integrate sine of sinus square x times u powered by 5 times du. After that, we need to, in order to change, in order to make everything to u, we need to subtract sinus square into 1 minus cosine square x.
Okay, so how do we get 1 minus cos square x in this case from sine square x? We got it from using the trigonometric identity formula sine square x plus cos square x equals to 1. And since sine square x was the subject in the previous slides, sine square x becomes 1 minus cos square x. Moving on, then since we let u equal to cos x, the cos square x value here becomes u square in the next value over here, so we obtain 1 minus u square to u to the power 5. Moving on, we multiply u to the power 5 into the values in the bracket. Then we obtain u to the power 5 minus u to the power 7, and then we integrate the values in order to obtain u to the power 6 over 6 minus u to the power 8 over 8 plus c. Now, some of you might wonder how do you get this value? Since integration is a reverse of differentiation, the power values 5 and 7, 1 is added to them, so we obtain u to the power 6 and u to the power 8, and then as we part the procedure, we divide the values with the new power. So u to the power 6 divided by 6 minus u to the power 8 divided by 8, and we got c because c was the constant that was differentiated and it became 0. So in integration it is brought back, and finally we substitute u equal to cos x. So we get the values cos to the power of 8x over 8 minus cos to the power of 6x over 6 plus c. And we are done.
Thank you for watching.